Hi, welcome to our Math. Today I'm doing a series of videos on systems of equations. So in this first video, I just kind of want to summarize the options you have since we will be doing systems of both linear and non-linear equations. For linear equations, you can have one solution. Over here, this one is no solutions. And this one right here, I know it looks like one line, but this is really you have two equations and you're solving them together and you end up with something that it's the same line. And this one isn't no solution. This one ends up being infinitely many solutions. All right, so this one is two solutions. We can see that. And I'm just going to say two, sometimes you have three solutions. So these are finite, this is infinite, this one is no solution. When you have one solution, 2, 3, 4, 5, up to infinitely many solutions, this is considered consistent. For all of these, consistent, consistent, consistent. I know this is going to sound insane, but when there's no solution, it is inconsistent. I know. Bizarro land. Consistent means there is a place where the functions touch. So if they don't touch, this is inconsistent. And then the last thing is if you have two distinct functions, they are considered independent. So that's going to work for all three of these. And then if it is the same line or the same function, they are considered dependent. So the last thing I'll say about this last one is a lot of times, so here, I don't know if you can see it very well, but this line is 2x minus y equals 1. A lot of times, you know, you might say infinitely many solutions, you might say consistent, you might say dependent, you might say same line. There's a lot of ways you can write this. Sometimes you give a set like A, and then you would solve this for y, so you would say negative y equals negative 2x plus 1. That you can't really see, so let's do that over here. Negative y equals negative 2x plus 1, and then divide everything by the negative 1. So y is 2x minus 1. So you would say x, comma, 2x minus 1. So when x is x, y is 2x minus 1. Sometimes they ask for a different variable, so like a and 2a minus 1. And that is just a way of saying infinitely many solutions, where you can have any variable for the x for your input, and then your output is based on your input. So this is another way of writing your answer in this scenario. All right. So I just wanted to tack on a simple, when you're dealing with these, you often check your work. So I wanted to add on the idea, if you have a system and you have a possible solution, it is really one of the reasons that people who like math is you can really simply check to see if you have an answer. So is 2, 2 a solution? If I wanted to test it out, I just put it into both equations. If x is 2 and y is 2, does that equal 0? Yes. That's not enough to tell me that that is the point at which the two lines intersect. I need to test it on both of them. So is 5 minus 2 minus 3, 5 times 2 minus 3 times 2, does that equal 6? 10 minus 6, it does not. So no, that is not a solution of this system. What about 3, 3? Is 3 minus 3 equal to 0? It certainly is. Is 5 times 3 minus 3 times 3 equal to 6? Is 15 minus 9 equal to 6? It is. So this is a solution to the system. What about negative 4, negative 4? Is negative 4 minus a negative 4 equal to 0? Well, minus a negative is plus a positive. Yes. But again, that's not enough. Is 5 times negative 4 minus 3 times negative 4 equal to 6? That's negative 20 plus 12. That's negative 8. So that does not work. Which brings down the really interesting question. If you have two lines, can they intersect at more than one point? That is a question for you to think about. All right, I hope you've enjoyed this video. Please subscribe to my YouTube channel and I'll see you on the next video. Thanks.